Okay, this is the jankiest setup I have ever had, and I have no idea if this is gonna work, but I'm going to try. Okay, I'm here to talk about mathematics. What math am I supposed to be talking about? Oh yeah, imaginary numbers and triangles. Okay, I'm gonna talk about triangles first because those are really cool. You've got a triangle, it's pretty simple. You've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And the rule of this triangle is quite simple. The rule is that every number is the sum of the two numbers above it. This is called Pascal's triangle. So 1 is the sum of 1 and 1, or 1 and 0, excuse me. 1 is the sum of 1 and 0, 2 is 1 plus 1, 3 is 1 plus 2, etc. It works. Great. Okay. And it's got some cool stuff, like what it actually is representing is the expansion of 1 plus x to the n. And it's representing the coefficients. This is called the binomial coefficient because this is a binomial. So when you have like 1 plus x squared, you get 1 plus x times 1 plus x. And when you multiply it out, you get 1 plus 2x plus x squared, and you see that the coefficients are 1, 2, and 1, which is this thing in the middle. So that's what this triangle is trying to do. But if we just look at the rule of every number is the sum of the two numbers above it, then the question is, what happens when you go up instead of down? Because it's really easy to keep going down. Really easy to keep going down. What if you go up? And when I first heard this, I was like, well, obviously that's impossible because you can't have numbers that add to 1, so two numbers, mystery A and B, that add to 1, but B plus this question mark will never equal 0. So what is the whole point of this question? It means nothing. And then someone said something very simple, which was they were like, what is B plus X equals 0? And I was like, well, oh wait, fuck. Oh shit, negative numbers exist. Oh geez, oh fuck. Now it's so much more complicated. And I'm like, wait, negative numbers do exist. They do. So if you just tell me A plus B equals 1 as a rule, so we know that because they add to this, whatever they are, they equal 1, we can be like, okay, we've put A and B there, so now what goes here, it's not a question mark, it's negative B. So B minus B, or B plus negative B equals 0. So negative B plus what equals this 0? It's B. And we keep going, and it's negative B, and it's plus B, etc. And on the other side, we have negative A, negative A, etc. And I'm like, okay, sure. But that's cute, but where do we go from there? And turns out you can keep going. You can be like, okay, you've got something that goes up, and we can actually fill this in as zeros vertically, and we can say 0 plus what equals B, it's B. 0 plus what equals A, that's A. So now we have a B here and an A here, and we're like, okay, cool. So, but now what? Because B plus what equals negative B, and we're like, ah. But remember, we know subtraction now. We can do negative numbers, so we can say it's negative 2B. And we're like, okay, cool. But negative 2B plus what equals B? And it's like, ah, the answer is 3B. And then, as you will easily see, this doesn't actually have any trouble filling out. And we can say, you know, what is... what goes here, and we can be like, well, this has to be B, because B plus 0 is B, and then B plus what is negative 2b, and we can be like negative 3b, and 4b, negative 5b. And it quickly becomes apparent that 1, negative 1, 1, negative 1, 1, etc. And going this way, we've got 1, negative 1, 1, negative 1 going that way. And if we tilt it, we have another Pascal's triangle. Negative 1, 3, negative 3, 1, 1, 4, and this is actually going to be like a 6, etc. You're going to end up with. And it just turns into Pascal's triangle going in every direction, which is crazy. And I thought that was really cool. But it doesn't really make sense because this is supposed to be 1 plus x to the n. So what do these numbers represent? And it turns out they still work because this middle row here is 1 plus x to the 0. Because anything to the 0 power equals 1, as you may know as a brilliant mathematician yourself. And that's really cool. But what about when we get above that? Well, what if it's 1 plus x? I'm trying to learn how to write awkwardly so that you can see it while I'm writing it instead of just after, to the negative 1 or to the negative n. And it turns out you can actually do that series, and it actually works really well. That 1 plus x to the negative 1 is x minus x plus x, or it's how do I say that? It's not x, but whatever you want to choose this to be, you end up with this sequence. And it's pretty cool. And there's some other algebra in it that you can do to prove that this works, but I'm not here for algebra, I'm here for cool visuals. And this is my cool visuals. It turns out you just have 3 triangles with some zeros in between all of them. And I thought that was really sick. So now you're forced to know it, which, yeah. Oh, and then I have one other thing, which is about imaginary numbers, aka I. Whoa. You. Wait, no, me. Which are pretty wacky. They're really unintuitive for me and for everyone I've ever talked to. And then I read something yesterday while I was trying to explain them to someone, and I was like, they make so much more sense now. And now you're going to be forced to know that too. So, sorry. Rough to be you, I guess. And the fundamental value of I, if you've ever looked at any kind of algebra problem, is I equals the square root of negative 1, which doesn't really make any sense because there's nothing you can multiply by itself to get a negative answer, because any number squared is positive. That's just the rule of math. If you have a negative times a negative, you get a positive. If you have a positive times a positive, you still get a positive. So what the fuck is this shit doing here? And it it's kind of weird. It's like, I don't get it. But I saw an explanation such that it's actually like makes sense, because I understand it from an algebraic perspective, like with the math rules, because I've like, you know, done a fuck ton of math my whole life, and I'm like, I know this shit, so I can do the I tables and whatever. But what does this mean? And it's, so I is a value that you attach to a number more so than a number itself. The same way negative is not a number, it is a value you can attach to a number. So you can have the number 2, and you can have the number negative 2, and the negative sign on its own is not a number, but it modifies the 2, and what negative means is like opposite. So if you have a number line that's got a 0 and a 1 and a 2, negative 1, negative 2, 2 made negative, so like you could have this segment. And if you make it negative, you instead get this segment. I should get multiple color pens. That would be so much cooler. Or I'll just, you know, use a stylus and be able to draw in multiple colors once I can find batteries for my stylus. But anyway, that's a totally other problem. So negative means opposite. So you go from this, and then you make it negative, and it just goes bajoof, completely flips over. It's now over here. Cool. So that's what a negative means opposite. And it's really easy to be like, okay, 2 times x equals -2, what is x? And we can be like, oh, well, that's easy. You just need to make it negative. So x equals -1. Really easy to figure out. So the thing you do to make -2 is multiply it by -1. So what is I? Let's say you had 2 times x equals -2. It's like, in other words, you would have 2x squared equals -2, and when you divide, you get x squared equals, I can't draw, I'm sorry, x squared equals 1, or sorry, -1, because you divide by 2, and then go badoof, badoof. And then you can take the square roots, and you get x equals the square root of -1. And it's like, okay, cool, that you can write that, but it doesn't mean anything yet. But if we stop thinking of multiplication as like a way to make numbers go together and start thinking of it as a process, like an operation, we get a whole nother thought. So with this, instead of thinking 2 times what number equals -2, we can instead think of it as what operation can I apply to 2 to get -2? And the answer was very simple. You flip it. I is rotation. Imaginary numbers, are rotations. So rather than taking 2 and flipping it, when you use I, you take 2 and you rotate it. So if I draw a new number line with 0, 1, 2, -1, and -2, if I've got 2 and I want to make it -2 with 2 operations, then I can say each operation is a 90-degree rotation. So I'm going to rotate it 90 degrees here. That's the first operation. And then 90 degrees here. That's the second operation. And I get -2 as my answer. So rather than thinking about this with like quote-unquote math rules, we can think like, what are we doing? And with negative, the answer is we're mirroring it. And with I, the answer is we're rotating it. So you go from this line to this line to this line. And this actually works great algebraically as well, because if we say I equals the square root of -1, I squared is -1 times, or the square root of -1 times the square root of -1, and a square root squared, you just remove the square root. So you just get -1. Because like anything else, like if you imagine like square root of 3 times square root of 3, that's square root of 3 squared. And you can just cancel those and you just get the 3. So we're just doing that same thing, but with -1, which is cool. And then you can do I cubed. So if you multiply -1 times this value, you're going to get -1 times I, which is just -I. And if you multiply this value by I, I to the 4th, you get what? And this is actually also pretty cool. You can think really easily of I to the 4th as I squared times I squared. And we know I squared is -1, so it's -1 times -1, and negative times negative is a positive. So I to the 4th is just equal to 1. And this works with our rotations, because 2 rotations, badoop badoop, got us to the negative value. So we went from 2 to -2. And if we did 2 more rotations, we would get back to the positive value. So what I does is it turns a number line into a 2-dimensional plane. So what you could think of is you could think of an XY graph, but instead of an XY graph, it's just numbers and their imaginary components. Where imaginary is a very poorly chosen word because it makes it sound like it's not real, and it's just as real as negative numbers. Which is to say, they don't exist in day-to-day life, but they're still useful concepts. So here you could be like, badoop 1, badoop 2, badoop 1, badoop 2, but instead of this being 1 and 2, this is 1i and 2i. So if you had a number like here, this would be 2 plus I. And if you had a number like down here, let's say, then you could say that's 1 minus 2i. That's what that point corresponds to. So this is what complex numbers are, like 1 minus 2i, or like if you've ever seen like 3 plus 5i as a complex number, it's because the I is moving it somewhere else on the graph, but it's up and down rotationally, basically, instead of just horizontally left and right. I don't know why I'm hand gesturing as though you can see my hand gestures, because you can only see them when they're over here. So when I do stuff over here, you have no idea, which makes it very unhelpful, but there you go. It's still cool. And yeah, it turns out you can do really cool stuff with this. Like on a really simple level, wave functions like this. So when these just like ba-doop, ba-doop, like any kind of sine wave or cosine wave or whatever. Wave functions like this really only have 2 values. So you can be like, the only thing we care about is what is the amplitude, which is like how far up and down does it go, and then what is the period, which is how long does it take to do that, which is 2 values that you can use to like describe a wave function, and or like a sinusoidal wave function like this, excuse me. But you can actually write those with a circle using I, which is really cool. So if you imagine a circle, we can describe the radius of that circle, r, as the amplitude of the wave. So that's like how far up and down does it go. That's the radius. And the period, which is how fast does it go up and down, we can describe using I, because I represents rotation. So more I means we're rotating more quickly around our circle when we make it. So using I, we can actually describe circles, or sorry, we can describe wave functions with just a circle. We can be like, look at the circle. We can do a complex number that will tell you how big the amplitude is and how fast it's going around. So that's pretty cool. And I like math. And there's your derpy lecture.